Good afternoon, everyone, the expert, our teachers, and my dear friends. I, on behalf of Cusrow Wadia Institute of Technology, Pune, would like to welcome our today's expert speaker, Ms. Lisa Karina Hiniuta ma'am. Today, she is going to share her expert knowledge regarding aircraft control and opportunities in avionics engineering. Before commencing with the lecture, I would like to share a few things regarding our expert Lisa ma'am. Ma'am has completed her diploma in Electronics and Telecommunication Engineering at our college, Kusrowadia Institute of Technology, Pune. She has received many certifications like QCAA certification, Safety Excellence Program, Qatar Civil Aviation Authority in March 2015, Certification Premium Service Excellence Program, Qatar Airways in October 2017, and Certified Crew Resource Management Instructor CRMI IATA training in November 2020. She has been the flight attendant in AirAsia Kuala Lumpur, Malaysia from January 2014 to January 2015. She has also been a flight attendant in the economy class in Qatar Airways, Doha from January 2015 to October 2017. And from October 2017 to present time, she is the flight attendant of the business class in Qatar Airways, Doha. She has more than 8,400 flying hours experience in international flight. She is also proficient in emergency situations, fully trained in CPR, AED, and Tempest IC. There is much more to talk about her, but now we are short of time, so I need to stop here. But we are so grateful to welcome such an experienced expert for this lecture. I am sure that everyone will enjoy this lecture and implement it in your future. On behalf of everyone, I once again welcome you, ma'am. Thank you.
Thank you so much, Soham, for the introduction. I hope everyone can hear me.
Yes, ma'am.
All right. So good afternoon, everyone. My name is Lisa Karina Nyota, and I'm from Shillong, Meghalaya. I'm currently based in Doha, Qatar, and I work as a cabin crew in Qatar Airways. And I'm also a IATA certified crew resource management instructor. Okay, so let me just give you a brief introduction on what is crew resource management. Crew resource management is the type of training procedures that is used it's a type of training procedures mainly for use for environment where the human factor can have a devastating effect, and where the human factors can affect the flight and cause that leads to accident and incident. Uh, Crew resource management focuses mainly on aviation safety, and it also teach the skills like leadership skills, decision making, and the communication skills inside the aircraft. All right, I will be sharing a few slides with you, and just give me a moment. In the meantime, let me share. All right, I hope you can see my screen now. If anyone can give me a thumbs up, or you can see my screen, right? All right. So first thing, I already gave my introduction. You can just have a look on a few brief introduction about me and a beautiful introduction about me. So moving on to the next slide. Next slide. Okay. Now, the agenda for today is I will be introducing to the IATA, which is the International Air Transport Association. We will be talking about the communication system. the aircraft navigation system, the aircraft lighting system, opportunities in avionics engineering, and if you have any questions or answers to me. So there's just one thing I wanted to tell all of you is that, first of all, welcome to whoever just joined just now. So just one thing is that I am I'm not really into the technical part of the aircraft, but I do have a few knowledge and a few ideas about the aircraft navigations, aircraft lightings, and the communication system, which I will be sharing with you today. And regarding the questions, I will answer as much as I can, but for the questions that I'm not able to answer, I'm very sorry, but I will definitely give you some suggestions from where to find the answers. All right, moving on to the next slide. That is introduction to IATA. Okay, what is IATA? It is an international air transport association. It is a trade association of all the world airlines. It was founded in 1945 and its headquarters is in Montreal, Canada. But they also have offices all over the world. But one of their main offices is in Geneva, in Switzerland. And as of 2022, it consists of 290 airlines from all over the world. Now, IATA is something which is the main association. So whatever the rules any airline has to implement, or the price fixing, it all goes through IATA. Without it always has to consult with the IATA, that's the International Air Transport Association, before they implement any rules or any price fixing. IATA supports all the airline activities and helps to formulate the industry, policy, and standards. Now, IATA also provides services like consulting, training. Now, for example, trainings for engineers, pilots, and flight attendant. Now, when it comes to safety training or the aircraft training, all engineers, pilots, flight attendants, and even ground staff of some department, they have to, once they are hired by the airline, they have to go through the training, which is only being certified by IATA. Because if the trainings are not being certified by IATA, it's no point. So IATA is like how we have in colleges, the universities, like for example, Pune University. Under Pune University, there's so many other colleges. So it's the same thing, IATA. So the same thing, IATA is association in aviation industry, and under IATA, there are so many other airlines from all over the world, and they follow the IATA consulting, the IATA trainings, and they follow the IATA rules for the price fixing and what are the next training that has to be implemented by the engineers or by the pilots or by the flight attendant. So this is a brief introduction about IATA. Like now we move on to aircraft communication system. Now there are three types of aircraft communication system. One is the primary, the secondary, and the third one, which is the satellite communication. Now for the primary communication, we use a very high frequency, that is the VHF. The range is 145 megahertz to 136 megahertz. And it is very clear. The line of sight is a straight line communication, but it has a limited range. It is free of charge. And the second one is we have is a second. In the primary range, it's a small range. It's not, you cannot communicate from, for example, from Doha to Mumbai. We don't use a very high frequency. For that one, we use the second frequency, which is a high frequency. High frequency is a very long range, but it is very fragile. The range is roughly from 1000 kilohertz to 18,000 kilohertz. It is not very clear in communication. It's easily affected by solar activity, mainly in the morning during the sunrise and in the evening during the sunset. But the good thing about the about the high frequency communication is that it is bend. It can bend. It doesn't communicate on a straight line because of its long range. So the communication can be bent. And the third one, we have the satellite communication. Satellite communication is chargeable. So for an airline to be using a satellite communication, the airline has to pay money. It is a very clear communication. It is a very easy to access. We in Qatar Airways, we do use the satellite communication because now we have been using this technique for quite some time now, but then a lot of airlines, they have just started implementing this new technique that is we call the metling. The metling is a group of doctors who are on ground, who only communicate with the aircraft which is flying, and this are in case if there we have a medical emergency on board the aircraft, because we as a cabin crew, we are only first aiders, we are not doctors. We can treat small sickness like nose bleeding or choking. We have been trained to do CPR and to even use a Tempest IC AED. We are being trained, but at the end of the day, we are not doctors. We cannot consult. We cannot confidently say what has happened to a passenger who is ill, or for example, what is the correct medication to give to the passenger, because we do carry first aid kit on board. We have the basic first aid kit, we have the aromatic first aid kit, and we have the enhanced first aid kit. In the enhanced first aid kit, we have injections and some very strong medications for heart attack, stroke, or even internal bleeding or shocked. So a few medications like that, although as a first aider we are being trained, but we are not so confident to we do need to consult the doctor. But not every time we are lucky to be having a doctor on board. So in a situation like that, we have to go to the flight deck, which is the cockpit, and then with the help of the pilots and with the help of the satellite communication, we do communicate with the doctors who is on ground, and they guide us what do we have to do next, what type of medication do we have to administer the passenger, or what is the next steps that we should take in order to avoid the situation from becoming worse. So this is a time when we use the satellite communication. And trust me, I have used it. It's a very clear communication and is very easy to access. So yeah, moving on to the next topic, that is the aircraft navigation system. Now in aircraft navigation system, first we have three types. That is the global positioning system. And first of all, before I start the aircraft navigation system, at the start of the flight, before we move, sorry, at the very start of the flight, before the pilot enter the aircraft to do with their pre-flight checks, the pilot, the first thing they do is they predetermine the route in the flight management system or the computer. They do have an iPad, which is provided by the company. They have their own applications, which is sync along with the computer system that we have in the flight deck. So what they do is they impose the route on the flight, like a moving map, which the pilot can monitor their screen throughout the flight. So the pilot can see other things around their flight, the flight path on their screen, like the airports, which is the nearest airport nearby. Is it a high terrain or a low terrain? Or if it's a bad weather, for example, turbulence. For example, if we move to, if we fly normally from Doha to Asia, like anywhere in Asia, in India or Malaysia, Thailand, normally it's not a very smooth flight. There's a lot of turbulence. So we as a cabin crew, we don't get to know like what are we expecting ahead. So what they do is we normally have a small meeting with the pilots before we start with our in-flight duty, and then the pilot debrief us. Okay, maybe after 1 hour we are expecting it to be a turbulence. So we have, and how do pilots get to know? They get to know through the navigation system. So We move now to the first topic, that is the global positioning system, which is the GPS, which we are using a lot lately. I guess everyone is using the GPS to go anywhere. So the global positioning system, it is the primary navigation source. It is mostly is the most accurate navigation system in the modern commercial flight, and it allows the aircraft to perform maneuvers at an accuracy of zero point 0.1 nautical miles. But there is a disadvantage of the GPS as well. And the disadvantage is that the GPS black spot, where it may not be enough satellite to range to obtain a position. So GPS is also subject in the jamming and interruption due to a few reasons, like there's always a problem everywhere. So even the same way with the GPS, they also face numerous interruptions like military conflicts. So now we move to the next one, which is the initial reference system. And the older version is called the initial navigation system. This is a self-sustained system that can be able to track the aircraft position with no external reference. It uses a combination of accelerometer and gyroscope to calculate any movement and acceleration of the aircraft across its three axes. Now, at the start of the flight, where the aircraft is on ground, the pilot setting up the aircraft is ready for the flight, and the pilot tells the IRS the aircraft exact location in terms of latitude and longitude. It then directs the acceleration across any axis and then calculates the aircraft position based on its movement. It requires no external, as I mentioned before, no external input other than telling where the aircraft is at the start of the flight. Now, there's a disadvantage of IRS as well. That is, it's not as accurate as GPS, and the position error, it increases over the time. So moving to the next topic, that is the radio aids. So radio beacons are normally located on ground, and it sends out the radio beams, which the aircraft's range and direction from the radio aids. Now this allows the aircraft computer system to calculate the aircraft location. The more the signal that can be detected, the more accurate estimated position is. Now, these radio aids are typically referred as a very high frequency omnidirection and radio range. That is VOR, which with associated distant measuring equipment. Now, other than all these aircraft navigation, we also have, as a part of the safety equipment, we have the transmitters. Now, what these transmitters, but these are not connected to the aircraft. These are external. Now, what the transmitters they do is that they, for example, if the aircraft is in danger, for example, if you're facing any we have to land the aircraft in the middle of the forest, for example. So how do we contact with the contact with the radio that we are in the middle of the forest and we need someone to send help? We use the transmitters, but there are two transmitters in the aircraft that is removable. That is, we can carry with us wherever we go. For example, we land in the ocean and we get drift away. So we take those transmitters with us, and these transmitters will send signal to the nearest, for example, radio aids or the satellite, or through the satellite, they're going to send the information that, okay, there is an accident in this particular place, and there are a few people who are in danger right now and who have to go and we have to go and save them, and this use the transmitters, and transmitters are also there in the RAF. That is the RAF is something. Okay, is a slide RAF. Okay, in case of emergency, in case we have to get out of the aircraft, we use the slide RAF. But in case we are landing in water, the same slide RAF can be used as the same slide can be used as a RAF. We use it as a boat to be floating in the water until the help arrive to until we get some help from the external people. Now, in the RAF itself, we do have some transmitters as well that gets activated the moment we activate the RAF. And these transmitters, they send information to the nearest place, to the nearest radio receiver, to send the information quickly that there's an accident or there are people to be saved. So there are many ways of navigation system in the aircraft. Now we move on to the next topic, that is the lighting system. Lighting system is a very, very vast topic, and that's why I have just prepared it in like a flow chart, because if I go on explaining this, it will take 1-2 days. So I will give you 5 minutes to copy this the flow chart, and I will explain a little bit on all the on all the 5 topics. So in the lighting system is divided into the 5 topics. That is the flight compartment, which includes the panel floodlights. It includes the integral lighting, the miscellaneous lighting, floor lighting, map reading lights, standby compass light, and the dome light. And we have the passenger compartment. The passenger compartment is everything which is inside the aircraft. Everything which is inside the aircraft is called the passenger lighting, and it includes the sailing, the sailing and the side wall lights, the dome lights, the boarding lights, the galley lights, the lavatory lights, the reading lights, and the ordnance light. And then we move on to the next topic, which is the service and maintenance light. And these lights are mainly for the engineers, because the aircraft don't always operate during the day. So it does operate at night, and we do land at night as well. And we do take off at night as well. So, and every time before the takeoff and before before takeoff and after landing, it is the duty of an engineer to service the aircraft and to have a look for each and every to check the aircraft basically if it's working or if it's fit to fly. Because even if there is one mistake in the air, even if there is one equipment or one compartment or even one chair that is not working, the aircraft is not fit to fly. This is the thing about the aircraft, because once we are in the air, there is no help. So all the help is on ground. So as an engineer, you have to be very particular with to be sure that everything, your state of mind, you have to be present at all time when you're on duty, because you have to be sure that everything, even one screw, it shouldn't be loose. Everything has to be fine, perfect. The aircraft has to be fit to fly. So that's why there is a service and maintenance light, which is in the nose gear, because lighting of gears is very important, because it has happened in the past where the aircraft took off perfectly fine, in flight perfectly fine, but when it comes to landing, the landing gear did not work, or the landing gear, they couldn't deploy the landing gear, so the aircraft could not land. So that's why there is a service light in the nose gear, because checking of all those gears and checking the gears and engine and fuel, everything, like I mean, while refueling the aircraft, everything has to be perfect. For that reason, even because most of the time we have to work, sometimes we have to work at night, and you cannot avoid that because this is the beauty of aviation. There is like 24/7 duty. There's nothing like, okay, I work only during the day, I don't work at night. There's nothing like that. It's 24/7. So that's why you need a good lighting system, even for the service and maintenance. We have it in the nose gear, the wheel well, the avionics compartment, and the aft equipment bay. Now we have these exterior lights. Have you ever seen the airplane flying at night? It looks very beautiful. It looks like a star that keeps blinking. And how are these happening? Because of the exterior light. There's this taxi light. The taxi light is the light that we use before takeoff or after landing, right after landing. And then we have these landing lights, and then we have the navigation position lights. We have the wing inspection light. We have the anti-collision lights. We have the beacon lights, and we have the logo lights. Now, exterior lights is one thing that will guide the aircraft, and not only will guide your aircraft or the aircraft where you're sitting on, it will also guide the other aircraft which is passing by, because it has happened so many times where you have the aircraft next to you, like while you're flying in 40,000 feet. So the aircraft, they guide each other using these exterior light. And then we have the emergency light, which is the exterior and the interior lights. Now the emergency lights are being used only in case of emergency, because if there's an emergency if there's an emergency situation during the day, of course there's the sun, you can see what's happening and everything. But if there's an emergency during the night, the aircraft lights, all the lights goes off, and the only lights that's on at that time is the emergency lights. The only lights that will be on inside and outside the aircraft is the only emergency lights after, which is after the emergency landing. And these lights are being controlled from the flight deck. Now, how these lights work? These lights don't work with the power of the aircraft, because normally after the emergency landing, the power goes off. And it's the emergency lights that work. But they don't work for long. Because they work on batteries. They don't work on the power of the aircraft. And the interior light and the exterior light, these are the lightings that will guide you where to go, where to exit the aircraft. And after exiting the aircraft, these lights are bright enough that they will show you the terrain, to move to which direction. Emergency lights are bright enough that they will lead you the way, to stay away from the aircraft, because after the aircraft have an emergency landing, you don't know what is coming next. Maybe the aircraft can go into a fire because of the fuel, or maybe some part can explode. So what the one thing you want to do after an emergency landing is run away from the aircraft. And how do you run away from the aircraft when the whole power system is shut? It's the emergency lights. The exterior emergency. First of all, the interior emergency lights will guide you how to leave the aircraft. We have the the luminescent strips. We have the sailing lights, and we have the exit locators that will guide you to lead towards the exit, towards the door. Okay, that we have to leave from this side of the door, and we have to go outside. And once we are outside the aircraft, it is the exterior lights that will lead us where to go, and what do we have to do next. Okay, this is all about the aircraft lighting system. Now we move to the next topic, that is, what are the opportunities in avionics engineering. Now, as an avionics engineering, you do have a lot of opportunities when it comes to aircraft engineer, flight engineer, and even a pilot. You can even become a pilot after avionics engineering. Now, I will tell you a few responsibilities of an aircraft engineer. Now, what an aircraft engineer do? Aircraft engineer is someone that builds the actual aircraft. It builds the aircraft from scratch. And you, as an aircraft engineers, you get hired by a company like Boeing, because Boeing, they build aircrafts, and Airbus, Bombardiers, and so on and so forth. Now, as an aircraft engineers, you are responsible for supervising and assembly of the aircraft system and engine. Like as I told you, since you are going to build an aircraft from scratch, so you have to assemble everything together. You build the engine separately, and you build the, for example, this the communication system or the control system. You build it separately, and then you assemble all of them together to form an aircraft. And it's as an aircraft engineer, you are also responsible for testing the aircraft to measure the performance and identify the areas of improvement. There is always a room of improvement. Even right now, we are, I mean, the companies like Boeing and Airbus, because these are the mostly used aircraft, which is the Boeing and Airbus. They've been mostly is the Boeing aircrafts and the Airbus aircraft that have been used uh, in um, in the commercial airlines, commercial for commercial aircrafts. So they try to improve a lot with the technology. For example, less like, you know, right now the latest aircraft that we've been using, that is the Airbus 350. The Airbus 350 most efficient aircraft. It uses very less fuel. It can go very fast, and it's a very light aircraft. It's not a heavy aircraft. Uh, Boeing 787, sorry, Airbus 350, Boeing 787 is also similar. Boeing 787 is an aircraft. It can go even on the higher altitude. Like both Boeing 787 and the Airbus 350, they can go on a higher altitude. They consume less fuel, and they go faster. So there's always aircraft engineers. They are always inventing new engines and new machines as years pass, which is a very good thing. And they develop a design specification for the aircraft system. And of course, like with new engine technologies, you want a new design as well. You want a better, like for example, right now in a Boeing 787, the window shades, you it's not like a how do we call it? It's not like a shade. You just close it. There's a button. There's a button. It just dim your window. This is the latest. This is the latest design that they have in the Boeing 787. They don't even have yet in most of the aircraft. I mean, uh, Boeing 777 doesn't have that design. It's only the Boeing 787 that have that design. It's a very beautiful design. And applying a scientific principle to improve the performance of the aircraft, like as I told you, as years pass, like now we have the new technology, which is the Airbus 350, and it is a very fuel efficient, and it is a very fast aircraft. And also uh, like it's environmental friendly. Now as an aircraft engineers, or we have to be sure that whatever we build is also aircraft like it doesn't have an impact of on the environment. Of course we cannot avoid it completely, but yes, we can always reduce it. And also as an aircraft engineers, you need to investigate the problem with the aircraft or the cause of accident. For example, lately, this is a new aircraft, which is the Boeing 737 MAX. It is a very new aircraft. It is actually the old one is just a Boeing 737 and the new one's a Boeing 737 Max. It is a very nice aircraft. Everything is perfect. But there have been a few aviation accidents because of that aircraft, and it has caused life of people. So as an aircraft engineers right now, they have stopped, I mean, a lot of company have stopped to order that aircraft, have stopped to order that aircraft, and they have also, uh, as an aircraft engineers, they are doing a lot of investigation to find out what went wrong with that aircraft. Why is the aircraft leading to accidents? So as an aircraft engineers, you also create the reports for the clients and provide the technical advices, and it maintain the aircraft and carrying out regular inspections. Now this is the aircraft engineer. Now we have one more thing, that is flight engineers. Flight engineers is even more interesting. You get as a flight engineers, you get recruited by the airline, not by the aircraft company, but by the airline. As a flight engineer, sometimes you have to travel all over the world. I mean, travel along with the cabin crew and the pilots, just to be sure that all the aircraft is working, that the aircraft is working perfectly fine while flying. Sometimes sometimes as a flight engineer, you have to because sorry, I'm a little bit lost. Because it's we do bring new aircraft every time, and there's always a new technology coming up. And some pilots, not all the pilots, are familiar with the new system, or not all the pilots are engineers. So they don't have much idea of the system, or the navigation system, or the small things. So for that reason, we have to they have to fly along with the flight engineers, just to guide them if they face any problem while the aircraft is flying. Now, the responsibility of the flight engineer is to ensure that all the components of the planes are working properly in order, and it is the duty to make and it is their duty to make any repair if there's any mechanical issue to arises. Now, the flight engineers, they play a very important role in an airline. For example, they check, as I told you earlier, they check each and everything inside the aircraft, inside, outside the aircraft. It is the responsibility of the flight engineer to make sure that everything works completely all right. Because even if one small mistake, it can lead to a lot of, it can lead to accident or even incident. So as a flight engineer, you have to make sure that everything inside, outside the aircraft work perfectly fine. Inside the aircraft, they have to make sure that all the handles are working properly, all the latch are working properly, all the seats are working properly. Because if it's a full flight and even one seat is not working, the aircraft is not good to go. The aircraft has to be on ground. If there is a small insect or a small bug inside the aircraft get grounded for 1 week. And as a flight engineer, you have to check each and everything, if all the wires, everything are working perfectly fine. Because a bug can it, I mean, this is funny when I heard it for the first time. Because if there's a bug inside the aircraft get grounded for 1 week, because the bug can eat the wire. It can lay eggs. It can it can damage the. For example, it goes inside the cockpit. It damages the wires. It damages the computer system inside the cockpit. So that's why, as a flight engineer, you have to be sure that everything works perfectly fine. There's no bug. All the seats are working completely all right. The computer system is working completely all right inside the cockpit and in the cabin as well. Now, it is the flight engineers are also are also used to interpret the complicated flight related codes and the instrument that helps the pilot with the navigation. Now, the flight engineers have an extensive role both on ground and off ground. Now, before the takeoff begins, what they do is they ensure it's safety, that it is safe to use. The aircraft is safe to use because at the end of the day, the aircraft is a machine. So they have to make sure that the machine, everything works completely fine. And they often have a pre-flight checklist. They have a list, and then they have to complete it before the plane is clear to fly. Now, once the plane is airborne, the flight engineer constantly monitors all the computer system and check if there's any abnormalities. Now, they are the expert on the plane mechanical instrument. Trust me, nobody knows the aircraft more than engineers. Engineers basically they work in the aircraft, they live in the aircraft. Flight engineers, it's the aircraft is like their baby. They know everything in and out about the aircraft. So they are expert in the plane mechanical instrument, including the fuel gauge, pressure indicator, wing flap, and even the landing gears. As a flight engineers, you have to check everything. The fuel gauge, you have to check the flap if it's working, the wing flap if it's working, because if the wing flap doesn't work, we cannot take off, we cannot land. It because if we do, we because if we do land with the wing flap not working, it's a sure shot accident. So as a flight engineer, you should you should really know that, or you should really check that if all the flaps are working, the landing gears are working properly, and it's not getting stuck anywhere. So the pilot normally they refer to the flight engineers to if they have any questions or concerns about the specific instrument and the operation. They also take a look at the weather patterns and determine the proper amount of fuel required for the flight. Not all the flights require the same amount of fuel. For example, if you fly as a flight engineers, you do have a knowledge if it's a nose wind or a tailwind. Now, if it's a nose wind, the wind is against the aircraft, so we need more fuel, and it will take because since the aircraft is going against the wind, it'll take longer. Hence, you require more fuel. But if the aircraft is in the tailwind, so it is pushing the aircraft. If it pushes the aircraft, so the aircraft move faster. In this way, you require less fuel. And as a flight engineer, you should have the knowledge of all of this. So they control the air conditioning, the cabin airflow, the main electrical system, and the engine power. Now, the flight engineers constantly collaborate with the pilot, determining if any specific adjustment need to be addressed. Now, after the flight, what do? They again once the aircraft is in this parking stand, what they do as a flight engineers, there are around mostly for one aircraft, there's at least 4 engineers taking care of one aircraft. The moment the aircraft landed, is in the parking, the parking bay. These 4 engineers, they go around the aircraft to see if everything still works perfectly fine. One of the engineers go inside the aircraft just to see everything is fine inside the aircraft, and all the components are functioning properly. They also have to write a flight report, so they need to have a flight log of the trip. If there's any problem it occurs during the flight, or if or in their duty, to file a proper report and contact the mechanics for repair. But normally what we do is, in my company, what we do have is called the cabin discrepancy logbook. So because not every time we carry a flight engineer when we travel anywhere, so sometimes we do not have a flight engineer. So we as a cabin crew, what we do is we write down, okay, in this flight, this compartment is not working. For example, the in-flight entertainment system is not working, or the Wi-Fi, because now lately in most of the aircraft and in Qatar Airways, all our aircraft has got a Wi-Fi. So sometimes the Wi-Fi is not working. So we noted down everything in everything in the flight discrepancy logbook, and after landing, the engineers come. They have a look on what are the problems, and then they go and fix it. So these are the duties of the flight aircraft engineers and flight engineers. And another opportunity in avionics engineering is a pilot. Becoming a pilot is not difficult. Anyone can become a pilot. All you have to do is after you're done, after you finish with diploma, or if you want to pursue after engineering, all you have to do is you have to enroll yourself in the CPL, and that is commercial pilot license. So you have to go and study so you can get the license for it. It depends on you. Like you can finish this training within 8 months. You can finish up to 2 years. It all depends on you how fast you can finish. But being an engineer, I mean, having a knowledge about avionics and becoming a pilot is the greatest advantage, because you don't have to consult the engineer for everything. Then you have your own knowledge. You can take a decision faster and quicker. And yes, I mean, you know that in the aircraft, the pilot basically don't fly the aircraft. It is the autopilot that take care. And with the help of the air traffic control, with the help of the air traffic control, they do fly the aircraft, because the air traffic control will guide the pilot which one is the near if sorry the air traffic control, they will guide the pilots for if we can move, for example, higher altitude, if we can go beyond, because most of the aircraft are flying in 38,000 feet or 39,000 feet, but we can go up to 41,000 feet. So, but it's not advisable every time. So, but it depends. With the help of the air traffic control, they can guide us accordingly. If we can go above 39,000 feet, or which airport is or which one is the nearest airport, because sometimes we fly over water. For example, we fly for 2 hours over water and there's no airport nearby. So it, with the help of the air traffic control, they will guide us accordingly, the how much speed, how much if we can go, I mean, the level, and which one is the nearest airport. Now we move on. This is for everyone. If you have any questions and answer, I am here to answer you. Right now, you can always unmute your mic, and then you can ask me the question you want to know. I'll be waiting here. Anyone has got any questions? All right. It looks like everyone understood, or I hope it wasn't too boring. So, thank you so much for giving me this opportunity to present to you all about the aircraft control and the opportunity in avionics. If you have any questions, like because actually I even give the floor to you all to ask a question, but it's okay, maybe you're shy or something. But if you do have a question, you can send me an email. I have my email address there, and you can also connect me in LinkedIn by Lisa Hinyota. So this is it. Thank you so much. And Yeah.
Hello, Soham. Can I give the vote of thanks?
Yes, please.
Is my voice audible?
Yes, you're audible.
Good evening, everyone. I am Preshit Gujar and I am here to present a vote of thanks for today's guest lecture. I would like to thank our guest speaker, Miss Lisa ma'am, for visiting and enlightening us with their knowledge. Today's lecture was full of knowledge and interesting things. It gave deep insights into the topic and also revealed some interesting facts. The point where Lisa ma'am told us about aircraft control and opportunities in avionics field was really informative. I'm pretty sure the precious knowledge that ma'am gave us will definitely help us in our studies and future career. Once again, I would like to thank Miss Lisa ma'am for taking out time from their busy schedule and enlightening us with the knowledge. Thank you so much. I would also like to thank Ajay sir for giving permission to organizing this guest lecture. Thanks a lot everyone for being a patient listener. Thank you, ma'am. Thanks again.
Thank you so much, Prashid. Once again, this is one advice and I would say one suggestions. I mean, not suggestions. It's more like a small advice to everyone, all the students, is that enjoy your time, know your skills, and once you know your skills, do what you love the most. Your job won't be a job; it will be a hobby for you. So I just want to wish all the best to everyone. The future is yet to come, is and just all the best. And if you have any questions, please don't hesitate to contact me. I will always be here to answer your questions. Thank you so much. And thank you, Ajay sir. It was a pleasure to give this lecture, and I'm very happy to finally be able to be the guest, to be able to give the lecture and be the guest lecture of the college. Once upon a time, I was a student.
Thank you, Lisa, that you are giving such a beautiful way you are presenting about the avionics. I think the most of the student, I think, enjoy your session. And it's a nice opportunity that you are with us, that all the juniors, they are getting to know what are the future opportunities in the avionics sector. Most probably these students are very shy. They are not going to ask such a
Yes,
question. Yes,
yes,
Prashant,
that's why
I
I
am
provided.
asking.
I'm sorry.
Mhm. I'm asking to Prashit and this the Parish, Rashmi. So they are, I think they don't have doubts. They are got the confusing between that of the this leading technology and the artificial intelligence and what are the changes in the electronics. I think they are what the little bit upset with this thing. So that's why
Oh,
the
all
Actually,
right.
very less
ma'am
questions
gave
comes
a,
in.
really informative lecture, so there were really few doubts. But I would like to ask you, ma'am, that have you been in any situation where you have faced a genuine problem while landing or while taking off, like a
Yes,
dangerous
yes.
situation?
Yes, I did face a situation, but mainly it was because of the weather. So mostly in winter, and because of the weather, we couldn't land because the wind was blowing too hard or something. Because if maybe if we would have landed, it was just the wind is just going to slide the aircraft. So which is again not safe. So we have faced a problem, which is a pretty common problem in aviation, that because of the bad weather we could not land or we could not take off because let's say it's too cloudy or the visibility is zero. So yes, we do face problem like that mostly in winter. I have faced problem like that where the aircraft almost landed, but it couldn't land, so it had to take off again. So yes, we did face a problem like that. So this is a time where we have to be prepared for anything that come, anything that come away. It can be an emergency landing or it can be anything like that. So we have to be well prepared for a situation like that. Thank you
Thank
so
you,
much.
ma'am. Thank you,
You're
ma'am.
welcome.
Good. Good, Prashit. Anyone again, any student, any girl student? Girl students are very shy.
Hello, ma'am.
Actually,
No
the
problem. Yes.
intention of a lecture to make to motivate them. And these girls students not coming forward. They have to come with that of the some kind of the questions.
Ma'am, I have one doubt.
Yes.
Ma'am, how are secondary frequencies affected by solar activities?
I'm sorry. Okay. You mean the sorry,
High
just give
frequency.
me a moment.
High frequency.
Okay, the high frequency. It's affected mostly mostly in the morning. That is when it's sunrise and sunset. That's a time that is being affected by solar frequency because it's a very fragile frequency. It's a weak frequency. It's not as strong as the very high frequency. That's why it gets affected easily by solar activity, but it gets affected only in the morning, that is during the sunrise and during the sunset. Yes. Hello.
Yeah.
I
Yes.
hope I have answered your question.
Oh, yes, ma'am. Yes, thank you.
Yeah.
Of course. Yes, Soham, any question? Abhishek, Gaurish, Rashmi. Okay, Prishit. If no one ready to question, so to conclude the session right now, Prishit.
Okay, sir. Sir, actually gave vote of thanks. I would also like to thank again Lisa ma'am for valuable time and knowledge which you shared with us. It was really helpful, and we will surely use it in our career. Thank you.
Thank you,
Thank you
Ms.
so
Lisa.
much.
Thank you
Thank you
very
Thank you,
much
again.
ma'am.
for this session. And I hope you will be remain in touch with us and you are sharing your the beautiful knowledge what you are gaining there. So it is not a joke like that. You are flying more than 8,400 hours. I mean it is a like that of the years and years what the you are flying. So that kind of the experience we are sharing. Really, it is a good to be the student point of view. Good to be the newcomers in what way in under which situation you are handling the this aircraft related situation, any worst situation. So this is the nice experience you are sharing with us. Thank you very much for joining for this session. Thank you, Lisa.
Thank you so much, Ajay sir. I really appreciate that you have chosen me to be the guest lecturer for
You
avionics, and I'm looking forward for more guest lectures in future.
yes, you are a right
Thank you
person.
so much.
You have a real time experience you have, and we want this kind of the personality we want.
Thank you. Thank you so much.
Thank you.
All right. Thank you, everyone, and I'll see you again.
And all the best to you for your the new ventures, new
Thank you.
assignment, your company offering you. Thank you very much.
Thank you very much.
Thank you.
All right. I will hang up now.
Yes.
Thank you.
Yes. Thank you.
Thank you, ma'am.